Hi, welcome back to Hello Agrarian channel. In our last video, we have seen solar constant and albedo. In this video, we are going to see different process involved in solar radiation. So, sun is extremely hot, it emits more short wave radiation, and once this short wave radiation reaching on the earth surface, so this short wave radiation convert into long wave radiation. So, this long wave radiation cause heating of the atmosphere. So, there are two kind of solar radiation, one is short wave solar radiation, another one is long wave solar radiation. So, there are two types of solar radiation. One is short wave solar radiation and second one is long wave solar radiation. Okay, you know it very well. The sun is prime source of almost all the energy on the earth. This energy is coming from the sun is known as solar radiation. The sun is extremely hot, emits this short wave radiation in the form of electromagnetic form. We have already seen in our earlier video about electromagnetic spectrum of solar radiation consisting of different types of short waves like X-rays, gamma rays, near infrared region and visible light. But most of this short wave radiation or short wave energy from the sun is not directly absorbed by the atmosphere. Now we will see what are the process involved in incoming solar radiation. Process involved in incoming solar radiation. You see, the uppermost atmosphere of the earth receives about 1 part of the energy out of 2 billion parts radiated from the entire surface of sun. So, this much tiny energy is responsible for all the action occurs in the earth. So, for an example, our atmosphere receives only, suppose sun emits 2 billion parts of solar radiation, out of which our atmosphere receives only 1 part. So this much this much tiny energy responsible for all the reaction and all the action taking place on the earth surface. So there are three processes involved with the incoming solar radiation. The first one is reflection, second one is scattering and diffusion, and the third one is absorption. Okay, so these are the three processes involved in incoming solar radiation. So we will study one by one. The first one is reflection. Reflection means it is returning something back from where the something was coming. So that is called reflection. Okay. So returning returning something back from where something was coming. Okay, so this is called reflection. So you also know it very well. When the light passing on the mirror, it reflect back. Okay, similarly, as you bring a mirror to the sunlight, a bright beam of light is thrown away from the mirror. So for an example, suppose this is the mirror, and when the sunlight passing in this angle, it reflect back. Okay, so this is incident radiation, this is incident radiation, and this is reflected radiation. Okay, so the angle of light reflection is dependent on the angle of incident radiation. Okay, so suppose the angle of reflected radiation is dependent on incident radiation angle. So the angle, this is angle of incident radiation, and this is angle of reflected radiation. Okay, so this angle of reflected radiation is dependent on the angle of incident radiation. You find that, so this angle of incident radiation and angle of reflected radiations are equal. So the smooth surface or relatively smooth surface shows specular reflection. So when the solar radiations fall on the smooth surface, it shows specular reflection. Likewise, so in this case, both this angle of incident radiation and angle of reflected radiations are equal. So it shows specular reflection. Okay, so this is on smooth surface. Okay, this is on smooth surface, while on rough surface or undulated surface, the radiation showing diffused reflection. So that means the angle of incident radiation and angle of reflected radiations are not necessary to have angle same. Likewise, so this is on rough or undulated surface. Here it is showing diffused reflection. Okay, so on smooth surface, the reflection is specular, and whereas rough or undulated surface, the radiation showing diffused reflection. Okay, the certain amount of incoming energy is lost that does not participate on the heating of the atmosphere. It is generally expressed in percentage of incident reflection. it is expressed in percentage of incident radiation. Okay, it is also called albedo or coefficient of reflection. It is also called albedo or coefficient of reflection. Okay, in our last video we have seen about this albedo. Albedo means reflection of radiation without changing any its quality. Suppose solar radiation coming in the form of short wave radiation, so the same short wave radiation reflected back to atmosphere, so that is called albedo. Okay, so this coefficient of reflection or albedo value is from 0 to 1. Okay, 1 as a maximum and 0 is lower. Okay, so it's the ranges between 0 and 1. So this is about reflection of incoming solar radiation. So reflection means it's returning something back from where something was coming. So the angle of this angle of incident radiation and this reflected radiation angles are equal. So that means this reflected radiation is totally dependent on incident radiation. Okay, on the smooth surface it shows specular reflection, whereas on the rough surface or undulated surface the radiation shows diffused reflection. Okay, and it is expressed in percentage of incident radiation. It is also called albedo, or you can say coefficient of reflection. The ranges between 0 and 1. Okay, so this is all about reflection. So I can delete it now. Second one is diffusion and scattering. Diffusion means spreading of something more widely from its center to all direction. Okay, you see here, when sunlight falling at a common point, it reflect to all the direction. Okay, it reflect to all the direction, so that is called diffusion. Okay, so when the sunlight passing through a atmosphere, it has to travel through numerous suspended solid particles which are available on the atmosphere. So in this process the energy and light is diffused and scattered. Okay, so these suspended particles diffuse the light and energy. Okay, so these small suspended particles in the atmosphere scatter and diffuse the sun's electromagnetic radiation. Okay, so because of this reason we could find twilight before sunrise and after sunset. Okay, so due to this action we able to find blue sky due to scattering. Okay, scattering of light, and red sky. Okay, red sky you can find in morning or after sunset. It is due to the diffusion. Okay. So more scattering or diffusion is possible through long wave radiation. More scattering and diffusion is possible through long wave radiation. Okay. In our earlier topic about reflection, when the light falling on the smooth surface, it reflects in a same angle, isn't it? So that means same angle. So that is called specular reflection. Whereas diffuse scattering, if light passing through the suspended particles or minute solid particles of aerosol and gases, it passes through different particles and it is called diffusion. Okay, it is called diffusion. So it is called diffused radiation. Okay, so that means, so this diffused radiation, that means the light passing through different suspended particles and it causes diffused radiation. So I hope you all understand about this diffused or scattering radiation. Okay. Next one is absorption. Third one is absorption. So absorption means it is a state of being captivated. State of being captivated. Okay. So the elements like water vapor, gaseous molecules, suspended particles. So this all the suspended particles absorb the short wave incoming solar radiation. Okay. So like water vapor, dust particles and other suspended particles absorb incoming short wave radiation. Okay. So for example, oxygen and O3, that is ozone molecules, absorb most of the short wave radiation. Okay, most of the short wave radiation, but for relatively long waves they behave as transparency, but for long wave radiation it behave as transparency. So this is all about absorption. Next one is process involved with outgoing radiation. Process involved with outgoing radiation. So there are 4 different processes involved in this outgoing radiation. First one is latent heat, and the second one is sensible heat, and the third one is emission by clouds and vapor, and the fourth one is long wave radiation. Okay, so these are the 4 processes involved with outgoing radiation. The first one is latent heat, second one is sensible heat, third one is emission by clouds and vapor, and fourth one is long wave radiation. So we will study one by one. First we will study about latent heat. Okay, first we will study about latent heat. The first one is latent heat. Latent heat means it is the energy absorbed or released from the substance due to changing the phase. Latent heat means energy absorbed or released from the substance due to changing the phase. Okay. Suppose if a substance changing from solid to liquid, it absorbs energy from surrounding place. If this liquid further changing to gaseous, it need more energy. So this can be explained by a diagram also. Suppose we take solid substance, that is ice, as a solid. Okay, so when this solid melting to liquid phase, or you can say water at 0 degree Celsius through melting, it add 80 calories. Okay, 80 calories, and water is liquid phase. Okay, and when this water warming to 100 degree Celsius, okay, when this water warming to 100 degree Celsius, it add 100 calories. Okay, then this boiled water or this water converting into gaseous form. Okay, and converting into gaseous form, it add 540 calories. Okay, it add 540 calories. Okay, when the process is reversed, the energy utilized for changing the state of the substance, the same amount of energy is returning to surrounding. For example, when this gas condenses to liquid, condense to liquid, it removes 540 calories, and it's cool down. When the cool down the water cooling, it removes 100 calories, and it further freeze to ice. Okay, freeze to ice, it removes 80 calories. Okay, so you see here the latent heat of fusion. Okay, the latent heat of fusion is the latent heat of fusion is 80 calories. Okay, whereas latent heat of vaporization is 540 calories. Okay, so this is all about latent heat. Okay, so latent heat means energy absorbed or released from the substance due to the changing phase. So changing from one state to another state, it need more energy, and reverse process also involved. So in the reverse process, the same amount of energy returned to the surrounding from where it was absorbed. So that's why the energy neither destroyed or created. Okay, so this is all about latent heat. Then third one is sensible heat radiation. Sensible heat radiation. Okay, in our earlier topic, that is latent heat, energy required to change from one state to another state. Okay, whereas in this sensible heat the energy is needed to alter the temperature of a substance without any changing the state. Okay, so sensible heat means an energy needed to alter the temperature of a substance without changing the state. Okay, so just we need energy to increase or decrease the temperature only, and the substance phase is remaining same. Okay, it is possible by absorption of sunlight by the land surface, or even the air is warmed up by gaining the heat. Okay, possible by absorption of sunlight by the land surface, or even air is warm up by gaining the heat. Okay, so this sensible heat radiation and latent heat are responsible for gain or release of energy in atmosphere. Latent heat and this sensible heat are responsible for gain or release the energy in the atmosphere. Okay, so this is called sensible heat transfer. Next one is emission by vapor and clouds. Third one is emission by vapor and clouds. Okay, so what is emission? Literal meaning of emission is discharging or release of something. Okay, you see, huge amount of terrestrial energy released through vapor and clouds, isn't it? Huge amount of terrestrial energy is released through vapor and clouds. Okay, so it is responsible for the atmosphere heats up. Okay, atmosphere heats up. Okay, so this is about emission by vapor and clouds. And the fourth one is long wave radiation. Fourth one is long wave. Okay, long wave radiation. You see, a little amount of energy is directly released to the space by direct long wave radiation. It means this amount of energy is not trapped by the atmosphere. So that is long wave radiation. Okay, so once the sunlight reaching on the earth, so this sunlight directly released to the atmosphere. Suppose this is atmosphere and this is earth. Okay, so a certain part of radiation, okay, a certain part of radiation is directly released to the space by long wave radiation. So this kind of long wave radiation not trapped by any atmosphere particles, and this long wave radiation does not impact on heating of the earth. Okay, so this is called long wave radiation. So this is all about this process involved in outgoing radiation. I hope you all understand what we have discussed in this video about different process involved in solar radiation, consisting of incoming short wave radiation and outgoing long wave radiation. If you have any doubt or query, you can give your valuable comments on the chat box. Thank you.